Next for us is to put the next resistors in. Now, contrary to following numerical values, I'm going to go to R5 next. And the reason I'm going to go to R5 is because R4 and R6 are right next to each other. R5 is a very delicate, fragile resistor. It's very, very small. When you compare it to the size of the other resistors, it is absolutely tiny. You can physically see the size difference there. So I like to get this one done early so that we don't lose it. The same technique applies. Pinch it, drag it round, insert it in, get it nice and flat, level, and then you can pull the legs out. Once I've got that one in, I'm then happy to put R4 and R6 in place and solder them all together. Okay guys, so that's now done. All our resistors are soldered nice and neat, and that's ready to go. The question we're going to first look at is the quality of our solder joints. So when we look at our solder joints here, we're going to look at a number of factors. The first thing we're going to look for is a dry joint. A dry joint is normally when the solder joint or solder has moved while it's been drying and setting. And that normally occurs when you've got vibrations, so your work is not held securely. And that's one of the reasons why we use bulldog clip. It stops our work moving around. And as it wobbles around like that, it can cause a dry joint. Or because you've got dirt and debris in your solder joint, and that's often caused by not having a clean soldering iron tip. So we're looking for that. And the best way to look for that is discoloration. You're looking at the colour of your solder joints. Once you've looked at the colour of your solder joints and you're happy that you've got no dry joints in there, and I'm looking at mine, and they're all shiny, they're all silvery looking, so they're bright metals, I'm happy that they are not dry joints. I'm then going to look for holes. Now when I look for holes, I'm looking to see, is there a hole in any of my solder joints? So are there any gaps in there? Are there any gaps around the joint? And I'm not seeing any. When I look nice and close, I'm not seeing any. I'm happy with that. The third thing we're going to look for is the amount of solder being used, and we can tell that by the shape of it. The shape we're looking for is this shape here. It looks a little bit like a circus top, a mountain, something's pointed towards the top, wide at the base, preferably with a cone or a curve going up towards it, an inward conical cone if we can. What we don't want is any large blobs. And if I look at this one here, one of the first ones I've done, it's quite blobby. There's a lot more solder there than I'd like. That is the limit of what I would allow myself. The reason we don't want too much solder is because if you've got a joint next to it, and you can see that some of these here are very close together, if you've got that and you have too much solder on both of them, when they connect, what you're going to end up with is what we call a short circuit. They're touching and they'll merge together, and that's bad for our circuit. As you know from a previous lesson, a short circuit is where the electricity will take a shortcut and it will not go where we want it to go, and the work will not do what we want it to do. The next component we're going to place in is going to be our switch. And the switch has got those really close terminals that we were just discussing. So the switch goes in here, and it's really important to remember to have the actual operating part of the switch coming off of the board. Common mistake is people turn it the wrong way around, so the switch is on this side, which then conflicts with your capacitor and your battery cables. Now, you push it in, you want to make sure it's nice and firmly down, and then we need to solder these parts here. There's a technique for soldering these, because they're so close together, and what we're aiming to do, we want to solder these without joining them together. If you are right-handed, like I am, when you are soldering this, you want to solder it so that you solder from left to right. And the reason you're doing that is you're going to heat up this joint here, and then the soldering iron is going to be leaning over the joint to the right. Now, if we've already got that soldered, it's going to reheat it and it could cause it to melt across. So we're going to solder from left to right. 1, and see that that joint that we previously soldered has not been touched. It's being left alone, nice and easy. If we were left-handed and holding the soldering iron in our left hand, we'd solder from right to left. This one doesn't require you to cut anything off. Check your joints. Are you happy with them? Yes, I'm happy with them. And we're going to move on. The next component we're going to do is our jack socket. Now this has got 5 legs on it, and it lines up with these holes on here. The important part is A, when you push it, you hear a little click, and B, all 5 legs are poking through. Look at it from various angles to make sure you can see all 5 legs. The most common mistake with this one is people forget to solder this leg here. So again, I'm going to go from left to right, not interfering with any of the previously soldered joints, and we're done. Now, you'll notice that my solder has got down to the point where I'm holding it very delicately. If your solder is down to the point where you are just about holding onto it, you have used it fully. That is now done with. Get yourself a fresh piece of solder, which I will now do. The last thing you want to do is burn yourself while you are doing this. Okay, the next component for us is going to be C2. Now C2 is one of our ceramic capacitors, and this goes in just here. And so you're aware, the reason for the order that these are going in, and the reason they're going in the order they are, is because we are going from lowest in relation to the circuit board to highest. That means those that finish closest to the board first. So the resistors, being nice and small, finish closest to the board first. Then we're going for the ones that are slightly above. The reason for that is when we turn it upside down, if it's going to lay flat at any point, we don't want what we're soldering to fall out. We don't want to give it an extra opportunity to fall out. Yes, we're going to push the legs where we can, but we don't want to give it any opportunity to fall out. There you go. One soldered C2. Next for us now are the 2 block capacitors, C4 and C5. These look from the side identical. The difference is the markings on top. And we need to get them the right way around. So I know that this one goes in here. And what I'm going to do is I'm going to line up. This is not strictly necessary, but it's one of them good standard practices to follow. Line up the writing on the component with the writing on your circuit board. That goes in there. Now these are very loose, as you can see, they fall out very, very easily. So we're going to have to delicately push the legs aside. So I'm holding it from behind, and I'm just going to push that leg off to the side just to stop it moving. And now it's not falling out. So that shows you that pushing the leg trick does really work. So now I can solder them, holding my work in the bulldog clip, and the same process applies. Now you might see a little bit of leg here that needs to be cut off. Be very careful not to cut too much off. And there we go, nice and happy with that. Checking my solder joints again, checking the shape, checking the colour, looking for any holes or any imperfections. I'm happy. Next for us is our LED. Our LED is a simple red LED, and what this does is it tells us if our circuit is on or off. Now there's 2 ways you can do this, and it depends on, and this will determine where you have it and when you solder it. I'm going to have mine laying flat along here, so it pokes out the front like that, next to my jack socket. And this just gives me the indication near the switch, so I can look at it from that end and I can see it's on or off. Some people might choose to have theirs on the board like that, in which case it would sit quite high, and you do this one after the next step. So I'm going to place mine in here. Now, if you look at the circuit board here, you can see that it's not a circle. There's a flat line along here, and that's on the negative leg. The positive leg is up here, the negative leg is here. We should know that positive leg is the long leg, negative leg is the short leg. When you're looking at the shape of the LED though, you notice that there's a flat spot on it on one side. The flat spot is just here. There we go, I've managed to actually focus in close enough now. You can see that on the left hand side of the screen, you've got a flat spot. On the right hand side, it carries on curved like the rest of it. And that flat spot is attached to our negative leg. If I hold it up here, you can see the flat spot is at the top, up here, and that leg there is our negative leg, that's our short leg. It is a little bit tricky to see, but that's why they give you two methods of identifying the long leg and the short leg, or the positive and negative, just in case. If you accidentally cut both your legs to the same length, or someone else does it and gives it to you, you can at the very least try and find the flat spot to indicate it for you. So this is going to go in these holes here. And as it goes in, I'm only going to put mine in a very short way. And once it's in a short way, I'm going to bend it round. And what I'm aiming to do is have it going flat and just hanging off that edge there. There we go. I'm happy with that. I can now solder that in place. We're now getting to the point where we're looking at some rather delicate components. Capacitors, LEDs, they can be quite delicate. So we can't spend too long when we're soldering these. We have to be relatively quick. So, now we've got these done. The next thing for us is our IC holder. This is the bracket that holds our integrated circuit board. And this is going to sit in here. Now, what you might notice is that there is a little groove just in the top here. Quite hard to see, but there is a little tiny groove there. The other end does not have it. If you can't see it, it's not the end of the world, don't worry. You can just about make it out there. That groove lines up with that little notch symbol there. And this just shows which way round it goes, because this will line up with the circuit board, because this will line up with your IC, which will have that same marking. Now, before I go any further and solder it, I'm checking that all 8 legs are poking through. I'm looking at an angle, I'm looking at a different angle, just so I can see all 8 legs. Because what you don't want is any of these legs to be folded over and not sticking through. And then using the same technique, not crossing over, solder these in place. And there you go. When you look at that, you've got multiple very nice solder joints. That is what you are aiming for from your soldering, that quality there.